So now we're going to use the rules of manipulating surds to express given surds in different ways. So this is our first one, square root of 80. Now I have a think about this and I spot that 80, that equals 16 times 5. I found a square number which is a factor of 80. 16 times 5 give 80. So that means I can express square root of 80 as square root of 16 by 5, and then I can actually work out the square root of 16, so it's no longer in the square root. So the square root of 16 is 4, so that can come outside of the square root, but we still got 5 inside, so square root of 80 can be expressed as 4 root 5. If I take the square root of 108, square root of 108 is the square root of, it could be 9 times 12 and that would give us, take the square root of 9 out, which gives us 3, so that gives us 3 root 12. That's not actually the simplest surd, because another square number that's a factor of 108 is actually 36. So it's actually, 108 can be 36 times 3, and the square root of 36 is 6, so that can come outside of the square root. So that can become 6 outside of the square root, because I can actually work that bit out, and then root 3. And that's the simplest surd that we've got, so it's actually 6 root 3. Question 2 here is asking us to do the reverse process, and it's got 7 root 5 and just want to be root over n, root of a single number. So we take the 7 inside the square root. So if we take the 7 inside the square root, we've got to square it. So that becomes, if we square the 7, it's the square root of 49, which we know is 7, times 5. And if we multiply that out, that becomes the square root of 245. And this one here, 4 times the square root of 11, well, if we take it all under the square root, so we square 4 to get 16, so under the square root it's 16. The square root of 16 is the same as 4 outside of the square root, so that's going to become 16 times 11 inside the square root, which becomes 176 for that one, so it's root 176. Question 3. And when we got numbers and surds mixed together, we just multiply the numbers together to give us 3 times, I'll write it out differently, I'll write it as 3 times 5 times root 2 times root 13. Now the 3 times 5 is going to give us 15, and root 2 times root 13 is root 26. We just have to see, can this root 26 be broken down any easier? Has it got a factor of a square number? 4 doesn't go into it, 9 doesn't go into it, 16 doesn't go into it, and 25, so that's the smallest it can go. So the answer is 15 root 26. And with this last part here, let's take the numbers. That's 2 times 4 times root 10 times root 15. The 2 times 4 gives us 8, and that gives us root 150. 150, however, can be expressed as 25 times 6, and 25 is a square number, so that's 8 times the square root of 25 times 6, and then we can take the square root, actually work it out, take it outside of the square root, so that's going to be 8 times 5 root 6, because the square root of 25 is 5, so that gives us 40 root 6 as the answer to part B. Question 4 is asking us to add surds together. Now, when you add surds, you can only add surds of the same type. So the first question is quite straightforward because they're both root 3. So you've got a root 3 plus 4 root 3. That's simply going to be 5 root 3. Part 2, you've got surds which are not of the same type. You've got a root 5 and a root 20. Now this is a GCSE question, so you can assume that you can make them of the same type. And in fact, root 20 the working out is that's going to be 2 times, and 20 is going to be 4 times 5, isn't it? And then that's going to be minus 3 root 5. And the 4 can come outside to give us 2 times 2 root 5 minus 3 root 5. And that's 4 root 5 minus 3 root 5. And thus the answer is just root 5. Next question. Neither of these surds are in their smallest form, so you've actually got to reduce both of them into their smallest forms. This first one here, that can be broken down into the root of, it's 16 times 5 is 80, 16 times 5 plus 2 times, and root 45 can be 9 times 5. So they're both now in terms of 5. 16 root 5, the 16 can be square rooted and taken outside, so that's going to be 4 root 5 plus 2 times, and the 9 can be square rooted and taken outside, so that's going to be 3 root 5. So that's going to be 4 root 5 plus 2 times 3 root 5 is 6 root 5, which equals 10 root 5. The next type of question you'll have to do with surds is multiplying expressions containing surds. Here we've got a double bracket, so I'm going to use FOIL. The first terms have given me 8, the 4 times of 2. The outside term is 4 times minus root 3, which is minus 4 root 3. The inside terms give me plus 2 root 3, and the last terms give me, it's plus root 3 minus root 3. I'm going to actually write that down as minus root 3 times root 3. That gives me 8, and then these simplify to give me minus 2 root 3, and then this minus 3 root 3, 3 root 3 is just 3, isn't it? So that's just minus 3. It might be easier to see it as 8 minus 3 minus 2 root 3, because then you can see the 8 minus 3 gives you 5, and your final answer is 5 minus 2 root 3. If I have a look at the next one, part B, again I'm going to be using FOIL. So the first terms are root 7 times root 7. You can either write that as root 7, or some of you will just write that as 7. The outside terms give me 4 times root 7. Inside terms give me minus 4 times root 7. And the last terms give me minus 16. So that comes to 7, as I've already worked out. They cancel out because they're minus and a plus. And then we get minus 16, and 7 minus 16 is minus 9. Question 6 is really the same as question 5, except for the surd expressions we're multiplying aren't the same. They are the same, they're squared. So root 8 squared is same as root 8 times root 8, which you know is root 64, it's just 8. And this next one, part B, write it out in full. Whenever you get the squared bit in there, write them out in full. So it's 4 minus 3 root 6 times 4 minus 3 root 6, and then apply FOIL. So the first terms come to 16. The outside terms is 4 times minus 3 root 6, that's minus 12 root 6. The inside terms are also minus 12 root 6, and the last terms are going to be minus 3 root 6 times minus 3 root 6, that's plus 3 times 3 is 9, root 6 times root 6 is 6. So simplifying that a little further, that gives us 16 minus 24 root 6 plus 54. I can do the 16 plus 54 to make 70, and minus 24 root 6, and root 6 is a simplified surd. And the last type of question you get with surds is having a surd in the denominator of a fraction and rewriting the surd so the only surd that exists would be in the numerator. So to do this, it's a technique where you just multiply both top and bottom of the fraction by the surd in the denominator. So this is 42 over root 12. I multiply both the top and bottom by root 12. So at the top it gives me 42 root 12, and at the bottom it actually gives me 12. So I've now got rid of the surd in the denominator. I can cancel out a factor of 6 there, so that's going to give me 7 root 12 over 2. But root 12 can actually be expressed as, don't forget, root 12 equals root 4 times 3, which equals to 2 root 3. So instead of root 12 I can write 2 root 3, so that equals 7 times 2 root 3 over 2, which is 14 root 3 over 2, which equals 7 root 3, which is what we're asked to find, so I like ending it with a QED, Greek or Latin for as asked to be demonstrated. Part B, same approach, just got a more complicated numerator, but I effectively have my root 20 plus 15 over root 5, and I'm going to bracket that together and multiply top and bottom by root 5 over root 5. So the top becomes root 20 times root 5, which is going to be root 100 plus, and then 15 root 5. And the bottom root 5 becomes just 5, so the surd has gone from the denominator. Root 100, that's just 10 plus 15 root 5. Instead of doing the denominator underneath the whole lot, I could actually split it up into that if it makes more sense, and then that's 10 over 5, which is 2, plus 15 over 5 is 3 with the root 5, so that's the answer.